Welcome back, my dear students. Now we are in the fourth lecture, module 4a, Orifice and Mouthpiece. In the previous class, we discussed about definition of coefficient of velocity, coefficient of contraction, and coefficient of discharge. In the present class, we will be discussing about how to determine experimentally these coefficients, coefficient of velocity, coefficient of contraction, and coefficient of discharge. How to determine theoretically. Okay. First, we will concentrate on coefficient of velocity. Okay, how to determine practically. You will be having a laboratory for this one. Okay, in the higher semesters you will be seeing. See, we will be having one tank and tank with orifice with known diameter. Means diameter is known means that its area is known to us. Okay, then through this there will be a water jet coming out. This is the water jet coming out. Okay. And there will be a constant head maintained here. How the constant head maintained? Here we will be having one tap. Through this tap water comes, and this tap can be regulated with a valve. And here how much discharge is there? Outgoing discharge. The same discharge if you put in input, then you will maintain the head. It is constant. This head is measured from the free surface of the fluid to the center of the orifice. Okay. We will provide one scale here, one longitudinal horizontal scale we will provide here, and even we will be having one vertical scale. Okay. Randomly we will fix this point. We will fix this scale, and we will note down. We will mark one point in the water jet, and we will be knowing this point here. This point here. Usually, this point we will be considering calling it as a section at vena contracta. That I will call 1-1, and this is the section randomly selected in the water jet. Let us consider this point is at a distance x from the section 1, and vertically it is y distance from the mark. Okay, not from here. It is y distance from the center of the orifice. Let us consider this is a y and this is a x. Means this particle in x direction, in horizontal direction it moved about x distance, and in vertical it moves about y distance. Okay, it might be in centimeter, meter, whatever it is. Now I consider this point P now. Okay, we will concentrate on this point. This point is traveled from 1-1 to 2-2, means it has traveled some distance. It traveled some distance of x in horizontal, therefore, and it took some time also. That time is called as t. Therefore, you got velocity of that particle which is traveling from one point to another point. Therefore, I can consider it as like this. This I will write it t is equal to x by v. I will use this expression later. Okay, you can call this expression as equation number 1. Now I will go to freely falling particle. In kinetics you will be studying. There will be 3 equations for uniform velocities. Acceleration, relation between acceleration, initial velocity, final velocity, and there will be 3 equations. For your understanding, I can write here, that is S is equal to ut plus half at square. I think you know this equation. Like that, S is equal to, V square is equal to U square plus 2AS, another equation. Then we have another equation, U equal to U plus AT, V equal to U plus AT, like that. Then in this one, I will consider the first equation. Let us consider at 1-1, the point started, therefore initial velocity is 0, and the particle is moving in y direction. Y direction means vertical, means there will be a gravitational acceleration come into picture. Therefore, I can modify this equation and write it for y. Y is the distance traveled by the particle in vertical direction, that's equal to half into gt square. Okay, now I will call this as equation number 2. Now I got an equation for x also, I got equation for y also, and the first equation modified to in terms of t, and the second equation as it is. Then now y is equal to half into g into this t is there. T I will write that t square means x square by v square I can write here. Then v square I will bring it this side, half g x square divided by y is the expression for v square. Then what is this v is equal to? V is equal to half g x square divided by y, its root. Okay, and this equation I will call it as a theoretical or practical. This is the actual equation. Why actual? Because here the particle movement is considered and it is measured actually. Therefore you are writing x and y equations, that terms here. Therefore this is the actual velocity. Now you got actual velocity, right? I will write it here, that we got an expression for actual velocity is equal to root of half gx square by y. Then what about theoretical velocity? We already derived in a previous class 2gh. Now define CV. CV is actual divided by v theoretical. Then what is actual? Actual is root half gx square by y divided by root 2gh. On simplification, you will get CV is equal to single root. Half and by 2 becomes 1/4 and g cancels and x square divided by h. X square by yh. This y is also there. YH. This is a expression for CV. Means what? In practically in the laboratory, you can just measure X and Y and the water standing in the tank, then you will get a CV value. Right? Now we will discuss about coefficient of discharge. How to find the coefficient of discharge? Very easy it is. Okay. Now look at here. I have a tank here and we have a orifice here and its diameter is known, therefore area is known. Then here water is stored and it is standing here, then some arrangement as it is explained in the previous slide. Then h you can measure, constant head you can measure from the center of the orifice to the free surface. Then if you know h, you can calculate v theoretical. We know this one, root 2gh. Okay, means from this I can understand that I can calculate that q theoretical, very easy, that is area into v theoretical. Then area you already know, v theoretical is 2gh. Okay, means q theoretical we got it. Now what about q actual? Okay, first tell me what is the meaning of q. Q is the discharge. How we measure discharge? Volume of water moving to time. Okay, it means in a particular time how much water you can collect in terms of meter cube or in terms of volume, that is your q. Means what I do here, water jet is coming, I will take one container, the container volume is known to me, this container volume is known to me, some marks are there here, I know the volume of this one, means v is known to that. Okay, volume. Then I will use a stopwatch. I will use a stopwatch, and when this water starts coming in inside, then I will on it. Then when it comes to the mark which I marked here on this tank, then I will off it. Means what? I will come to know the time required to fill this container. Okay, I will note down the time required to fill this container or time required to get this much of volume of liquid. Then you will get this one as a q actual. Over. Okay, you will write this volume in meter cube and time you will write in seconds, then you will get a q actual. Then what is the definition for cd? Cd is q actual by q theoretical. Over. Q actual is what? It is determined in the laboratory by taking a container, that is your Q actual, by area into root 2gh. Over. It is defined. Then coming to CC. Okay, CC we have a very interesting thing, because CD it is already derived like CC into CV. Therefore CC you can calculate it like CD divided by CV. This is determined practically. This is determined practically. Therefore you can get CC value. Thank you very much. In the next class we will solve many problems. Thank you.